Hi students, how are you all? One question. Are you in pressure? Then some will say no, we are not in pressure, or some will say that yeah, we are in pressure. Few students will say no, we are not in pressure since we don't have school, we don't have studies, not classes, exam over, so we are not in pressure, we don't have any pressure. But my dear students, actually when we think that we do not have any pressure, but one pressure always there with us. What is that pressure? The pressure which air exerts on you. Understood? Because you are immersed in water. Water? No, it's air. So when you are immersed in air, that means air is everywhere. So air is also giving pressure on your body. That means you are in the pressure of air, which we call atmospheric pressure. Let me elaborate it. Say, this is our earth. Fine? This is our earth. Now, our earth is covered by the air. Actually what? If you go 300 kilometer up, understood? From the earth's surface you are going to a height of 300 kilometer, and till that level you will get air. That means air is here which is covering the earth. Okay? This total space is covered by air. Understood? This total space is filled with air, and this air is continuously giving pressure to earth. Understood? This air is giving continuous pressure to the surface of earth. Understood? We call it atmospheric pressure. Since you are on the earth's surface, so you are also getting some pressure which we are not realizing every time. Understood? So air is also giving us pressure. What I told, maybe you are not realizing it, but we are getting that pressure. Or you can also say that we are habituated of getting that pressure. That pressure is called atmospheric pressure. Who is giving that pressure? Air is giving that pressure. So what I told you, from the earth's surface 300 kilometer up till 300 kilometer, we call it air envelope. It's an envelope made up of air which is covering the earth. So this air is covering the earth and continuously giving pressure on the earth's surface. Understood? Now, our earth's surface is not plain. No, it's not a plain surface everywhere. Somewhere you will see that it's a hilly region. Okay? And somewhere you will see that it's down. Like, say, if you see, this is the hilly region, means hills. Okay? But here you will see, say this region is filled with water. I mean ocean. Okay? Sea. So this is sea. So these are hills, this is sea. And you should know that whenever we find something on the earth's surface, we take the reference of sea level. I mean, we will find the pressure, and where we will find the pressure? I mean the pressure exerted by air. Where will you find the pressure? We will find the pressure on the sea level. Fine. So always we'll take the reference of that sea level. So as I told you that Earth's surface is not plain. Somewhere you'll see that it's down I mean the ocean, the sea level, or somewhere you will see that it's high. Why? Because of hills. So now we will see the pressure exerted by the air on the sea level. Okay, only on the sea level. We'll measure the sea level, and depending on that we can calculate the pressure on other surface of earth. Fine. Now to find the pressure of earth, atmospheric pressure, we will use the device is called barometer. Understood? Or mercury barometer. So mercury barometer is the device by which we can measure atmospheric pressure. The construction of atmospheric barometer is very easy. I will tell you all. Now, see, for atmospheric barometer or the mercury barometer by which we are going to measure the pressure, to make that we have to take a vessel. A simple vessel. See, we are taking that vessel here. Fine. And we have to fill it up with mercury. Say this is mercury. Understood? What is this? Hg. Hg is mercury. Fine. Now, what we are doing? We are taking a test tube. A long test tube will take around 1 meter length. Understood? Test tube means this is the long test tube will take, whose height is around 1 meter, that is 100 centimeter. So we will take this test tube, fine, and we will immerse it this way, like this way will emerge. Understood? This is the mouth of that test tube. Understood? And we'll notice that this mercury level, the level inside this test tube is getting up, and somewhere here it will fixed. Understood? The mercury of this container, understood? The mercury of this vessel is going up. See, I am showing you the arrow. Says they are going up to the test tube, and you will notice that at a particular height it will reach, and then that will remain there, this particular height. Understood? Now if I ask you why this mercury is going up through the test tube, this mercury, why this mercury is going up through this test tube? Because of air pressure. I mean atmospheric pressure. Your air is giving pressure this direction. See, this air is giving pressure this way. This air is also giving pressure this way. This is air pressure. Understood? Since air is giving pressure from both the direction to the mercury, that mercury also giving pressure to the upward like this, and the mercury is going up. This level of mercury is going up. Understood? Now we can say that what is the pressure exerted by this much mercury? Yeah, not from here, from this level of mercury, this much. Fine. The pressure exerted by this much mercury equal to the pressure exerted by air. I mean atmospheric pressure. Understood? We can say that the pressure exerted by the mercury column, this is the mercury column, this much. Okay? This much mercury column, we can say that the pressure exerted by this much mercury column equal to the pressure exerted by air, because this column is created. This column was created because of the air pressure. the air pressure. The air is giving pressure downward. That's why this mercury is going up. So the pressure exerted by this mercury equal to pressure exerted by this air. That is atmospheric pressure. Now easily we can calculate the atmospheric pressure. How will you calculate the atmospheric pressure? The atmospheric pressure equal to the pressure exerted by this mercury column. Understood? Let us calculate it. Now, if I take the whole system, the whole barometer, mercury barometer, here in the sea level, understood? If you carry the whole barometer in the sea level, just on the sea level, you will see that the height of this mercury column, this much, this height is 76 centimeter. Understood? But if you take the whole barometer here on the top of the hill, okay, at the peak of the hill, you will see that the value which was at 76 on the sea level, now it is reduced to 76 to say 70 or 65 or 60. That depends on the altitude, that the height you are going up. Understood? So what I want to tell you that, say this is 76 on the sea level, and what will be the value of this mercury column on the top of the hill? Say it is 65 centimeter. 65 centimeter. So what I want to tell you that, so when you are going at up, when you are going to the peak of the hill, the height of that mercury column of barometer will reduce. As you are going up, the barometer height will reduce. That means the pressure decreasing there. Yes, when you are going up or when you are going in a hilly region, the atmospheric pressure there is less than the atmospheric pressure of plain surface like on sea level. So now we will calculate what is the atmospheric pressure, I mean the value of air pressure on the sea level, where we got 76 centimeter. Let's see. To measure the atmospheric pressure, just a simple formula you have to use. What is that formula? H rho G. Yes, H rho G, that is height of that mercury column in that barometer height, I mean that 76 or 65, wherever you are measuring. So just you have to carry your barometer over there, where in the hilly region or on the sea level, wherever you want to find the atmospheric pressure, just you have to carry your barometer over there and you have to see what is the height of that mercury column. And I told you that if you are taking that barometer on the sea level, you will get 76 centimeter. Yes, height of this mercury column is 76. So what the formula I said? H rho G. Let us write this formula. H rho G. Fine. I'll teach you to find the atmospheric pressure in two different systems. CGS system, SI system. Say this is my CGS. Fine. In CGS system we'll find it first. Then we'll find it in SI system. Okay. So what is the height of the mercury column on sea level? 76 centimeter. 76 into. What is the density of mercury? Because in barometer we used mercury. So what is the density of mercury? Yes, 13.6 gram per centimeter cube. So 13.6 gram per centimeter cube into gravity. The value of gravity in CGS system is 980 centimeter per second square. 980 centimeter per second square. Got it? Now, if you multiply all this Fine. If you multiply all this, what will you get? 1012,928 dyne per centimeter square. Understood? This is the atmospheric pressure in CGS system. Fine. Now in the SI system, how you calculate? Just you have to convert all this value in SI system. See how? Height 76, that was in centimeter. In CGS system it was in centimeter, 76 centimeter. You have to convert it into meter. 76 centimeter means 0.76 meter. 0.76 meter into 13.6 gram per centimeter cube. You have to convert it into kg per meter cube. Just multiply by 1000. That means 13.6 into 1000. That is, if you cancel point by 10, 0 cancel. So 13600. 13600. That kg per meter cube into 980 centimeter per second square. What is the value of gravity in SI system? 9.8. Okay, 9.8 meter per second square. So into 9.8 meter per second square. Now, if I multiply them, what I'll get? 101292.8 Newton per meter square. This is the value of atmospheric pressure in SI system. As I told you in our previous video, Newton per meter square is also called Pascal. So instead of Newton per meter square, I can also write Pascal. Capital P, small a. Understood? So you saw the value of atmospheric pressure in CGS system and also in SI system. What is the value in CGS system? 1012,928 dyne per centimeter square. This is in CGS system. What is the value in SI system? 101292.8 Newton per meter square or Pascal. These are the value. Now one more information for you. This value is called 1 ATM. 1 ATM means not that ATM from where we take the money. ATM means atmospheric pressure. Okay, 1 ATM. 1 ATM in CGS system, this is the value. And in SI system, 1 ATM means this. 1 ATM means 1 atmospheric pressure. Understood? So 1 ATM means 1 ATM means 1 atmospheric pressure. 1 atmospheric pressure means 760 millimeter of mercury pressure. Okay, or 76 centimeter of mercury pressure, or 0.76 meter of mercury pressure. Understood? 1 atmospheric pressure means 76 centimeter of mercury, as I told you. 0.76 meter of mercury we have already calculated, and in millimeter 760 millimeter of mercury. Okay, and this 760 millimeter of mercury is also called 760 torr, equal to 760 torr. TORR, it is another unit of pressure. Understood? So 1 atmospheric pressure means 760 millimeter of mercury means 760 torr, because 1 torr means 1 millimeter of mercury pressure. Understood? So 1 torr means 1 millimeter of mercury pressure. So we have seen that except all other pressure, always we are feeling a pressure which is given by air. We call it atmospheric pressure. Though we are not realizing it, but continuously we are getting that pressure because we are surrounding by air, and that air is giving us that pressure, atmospheric pressure. So I am sure that now you know what is called atmospheric pressure and how to calculate atmospheric pressure at any level of Earth's surface by using a barometer. And I am also sure that now you know how to calculate the atmospheric pressure in CGS, also in SI system. You must practice that. Thank you.